Okay, so our next lesson, guys, is on division of fractions. There are no vocab words on here. We will get into a nice little review on what division actually is. Okay, so division of fractions. Let's go ahead, and what you're going to find is that this thing is going to be just like Tuesday's lesson, just with one extra little twist to it. Okay, so what I want to start off with is this. Okay, I want to start off with a little bit of, like, I like calling it historical fiction. All right, meaning that I'm kind of making part of this up, but it is kind of in the rough area true. Okay, so many years ago, all right, when you have those people that, a lot of times a lot of mathematics comes from like ancient Greece. And so, in those times, people love to like fiddle with the discovery of mathematics. Okay, a lot of the stuff we know comes from that time, and so someone back in the day, they wanted to they're fiddling with the math, and what they decided is after kind of writing some things down, they already knew some kind of basic concepts, especially when it comes to mathematics. And here's what they knew. They knew their division, as a matter of fact. So let's just say 6 divided, the number or the problem, 6 divided by 2, that gave them the answer of what? 3. They knew that. 6 divided by 2 is 3. All right, and that's something we know now, right? They also realized that one half of 6. Like you have 6 hamburgers and you say, okay, I'm going to eat half of them. Well, they already knew that a half of 6 was what? It's also 3. And they looked and they said, that's kind of funny because this has some similarities to it. And after fiddling with it for a little while, they realized that, first of all, of is multiplication. When you're talking about part of something, you're actually multiplying it in mathematics. And then what they realized was they already also knew commutative property, meaning that you could flip-flop a multiplication problem, commutative property multiplication, like 2 times 3 is the same as 3 times 2. And they could flip this like that. So 1/2 of 6 can also be written like this and still get 3. Now, after doing this a number of times, they realized something. Even something like 6 divided by 3 gives you 2. 6 times 1/3 also gives you 2. And they recognized after doing a number of problems like this, there's a little bit of a pattern here. They knew that dividing by 2 was the same as dividing by 2 over 1. Or dividing by 3 was the same as dividing by 3 over 1. And they recognized that when you're dividing by a number, it's the same thing as multiplying by its reciprocal. So dividing by 2 over 1, you'll get the same answer as if you multiply by 1 over 2. If you're dividing by 3 over 1, it's the same as multiplying by 1 over 3. You get the same result. Therefore, this was discovery of what many of you guys learned last year in 6th grade of KFC. Okay? Yeah, some 6th grade teachers love calling it KCF because that's kind of the order you do it in, but KFC has a little more catchiness to it, so because we always think of Kentucky Fried Chicken. But yes, it's keep, flip, change. That's where that order came from, is because of pattern in mathematics that they have discovered that's how they work. So because the dividing fractions is so easy, they found a way around it. That if you, of course, keep the first number, you, of course, flip the second number, meaning write the reciprocal, and you change the sign from division to multiplication, you'll still end up with the same answer. So what we're going to do is we're going to use this to divide fractions today. All right, so hopefully you guys, a lot of you guys feel that this is some review today from 6th grade. All right, so here's what I would like you guys to do is go ahead And let's flip our book page, if you're not already there, to page 330. 330. Okay, on 330, here we go. What we have here is I'm going to go ahead and write problem number 2 up here. Number 2 is negative 3 divided by negative 6/7. Okay, so we can call this step star, since that's kind of what we called it last lesson. Remember, we're going to start by ignoring our signs. Okay, we'll worry about our signs. Don't forget our signs at the end, but ignore them for right now. Okay, step 2, or step 1, I guess. Step 1 is convert anything mixed number, or in this case a whole number, to an improper fraction. So I'm going to go ahead and put negative 3 over 1. Remember, if it's a whole number, you just put it over 1. I'm going to rewrite negative 6/7 because it's already just a regular fraction. I didn't quite ignore my signs right. I brought them down. It's not a big deal. I'm still kind of ignoring them when it comes to calculations. Now, we're not going to divide straight across. That's not the division way. What we're going to do now is step 2, and that is what we just talked about a second ago. Is we're going to use that pattern that was formed, right? What we call KFC now. We're going to go ahead and keep the first fraction. We're going to flip the second fraction, make it the reciprocal of negative 7/6. And now we're going to change the sign from division to multiplication. And now at this point, it should be reviewed from the last couple of days. So here we go. Step 3, I'm going to go ahead. If you want to multiply and reduce, you can. I'm going to cross reduce right now. The numbers are smaller. It's a little easier. I'm going to cross reduce. And listen, remember, I need to cross reduce now. If you try cross reducing while it's still division, you're not going to get the correct answer. Don't forget, cross reducing happens after it becomes a multiplication problem. So you have to do KFC first. So here we go. Cross reduce. 7 and 1 doesn't work, but 3 and 6 does. We can divide both of them by 3. 3 divided by 3 gives us 1. 6 divided by 3 gives us 2. And now normally what we'd keep as separate steps, I'm just going to call this one step, and that is we're going to multiply and simplify this problem. So 1 times 7 is 7. 1 times 2 is 2. Now comes another step star, right? And I'm just going to put the word signs here, because remember, we're now going to not ignore our signs. We're going to take a look. And this was a negative times a negative, meaning they're the same. So our answer is positive 7/2. And again, remember, if you want to change it to a mixed number, you can. 2 goes into 7 without going over 3 times. 2 times 3 is 6. And so, of course, the remainder between 7 and 6 is 1. Okay. And our denominator stays the same. So either one of those will work. All right, questions on division of fractions?
So to get them right, you don't have to simplify?
Cross-reducing is simplifying. Are you saying to convert it to a mixed number?
Yeah.
I'll take either one. And if you want to save yourself some time, then you don't have to, no. Guys, if the 7/2, remember, you might also want to double check and see if you didn't reduce it all the way here, you might be able to reduce it here. So this could be like, I don't know, 8 over 2, and that could, of course, reduce to 4 over 1. Okay, but that's not the case here, obviously. Okay, any other questions? All right.
Yeah, what exactly was step 1?
Step 1 is all I did was convert what we had was mixed numbers, but this one's not a mix, it's a whole number. I just made them to improper fractions. This one here, anyway. 6/7 was already what they call A over B form, meaning a digit over a digit, or number over a number, I should say. Okay, that's not a number over a number, or a mixed number is not a number over a number, right? So a over b form is just like an improper fraction form. Okay, other questions? All right. Okay, so here we go. Problem I want you guys to try out is off of your homework, page 331. Try out problem number 3. Problem number 3. Okay, I'll give you 1 minute. Go. Okay, anyone need more time? Okay, about 15 more seconds. Okay, guys, right now is the time to go ahead and get going on your homework if you're already done with that problem. Okay. All right, 30 seconds. Go ahead and turn to your neighbor and go ahead and share. Go.
7 and 25 over 4. I don't know how I got this. I think I was good. Oh, it's supposed to divide. Okay, I got that one. Yeah. My order was wrong.
Okay. Here we go. Here's what you should have had. First off, this isn't a whole number, it's a mixed number. I need to convert it. So 1/2 is ready to go, but 7 and 1/2 is not. So 2 times 7 is 14, plus 1 is 15. So we have 15 halves. And now, KFC. So I go 1/2. I keep my first, flip my second, becomes 2/15, and change my sign to multiplication. At this point, I'm going to go ahead and cross reduce. In this case, it's going to be basically a cross canceling because they just become ones. And what I end up with when I multiply is 1 times 1 is 1. 1 times 15 is 15. And let me double check, make sure, are there any negatives on that problem? And the answer is no, there were no negatives. It was just positive divided by a positive. So we have a positive 1/15. Okay? Questions on that problem? Okay. Okay, so we're going to get into some word problems. Okay. And if you take a look, right, this upcoming lesson here are all about word problems, and we have to hit word problems hard because our test, this upcoming test, it's going to have a lot of word problems on it, and it's not going to say off to the side, use multiplication here or use division here. You need to be able to decide which one to use. Okay, so working on these is something that we need to definitely consider. Now, I've taken a lot of time coming up to now talking about the concept of multiplication, kind of what it looks like in a word problem. The concept of division, what it looks like in a word problem. Okay, now let's go ahead and let's go to 330 and let's take a look at problem number 4. Okay, so if you remember, okay, division word problems, just kind of going back to our little fake story I gave you guys, right, a while back when we were talking about division. If you remember, right, I said, okay, guys, remember the marbles and the hula hoop, and you know, it's kind of like a first grade activity that you would have done in first grade. But I said, okay, guys, go ahead. Remember, we had a bin of marbles, right? Well, remember, a division problem would be something like, okay, guys, go ahead and grab 6 total marbles, and then come back and put them in the 3 hula hoops that you have. And the question would be, of course, how many go in each hula hoop? Okay? Remember, I was giving the total. That was the whole point of division. You're getting the total amount, in this case, the total marbles. You're getting the number of groups. They want to know, of course, what's the size of each group? How many marbles go in each group? Okay. Or, of course, the other one I said was, you know, you have 6 marbles. Make groups of 2, and then I would then ask you, how many hula hoops do you need? Okay, so remember, you're getting the total, and then you're finding, they're either giving you the number of groups that you need to make, or they're giving you the size of each group. In this case, how many marbles are in each group, and asking you how many groups are needed. Okay, so that was just a little review of the little fake activity we talked about a while back. Okay, I'm going to revert back to this during this story. Okay, so number 4, let's go ahead and close read. Remember, close reading. We're gonna read it together. When I stop, you say the next word. Okay, here we go. Number 4 on page 330. On Saturday, Lindsay walked 3.5 miles in 1 2/5 hours. What was her walking pace in miles per hour? Write it in simplest form. Okay, so now this can be a little challenging. All right. So remember, we talked a little bit about this. You're gonna see me use a couple of different strategies. I'm gonna go ahead and I'm gonna use a diagram. In this case, let's say this is a map. Okay. It's only a line with a couple of inlines, right? But let's just say it's a map. This is like the trail she walked. Okay. And when Lindsay walked, this total amount of distance she walked was 3.5 miles. Let me go ahead and actually I'll use a black line to separate the last 2 problems here. So we have a total of 3.5 miles. Okay. Now it says that she walked that in 1 2/5 hours. Okay, 1 2/5 hours. Now, here's the thing. If she walked, let's say, well, I'm going to round up. Let's say she walked 4 miles. Okay, and she walked that. Okay, in 2 hours. Here's hour 1 and here's hour 2. It will say, how much did she walk per hour? Guess what that's asking, guys? It's asking, how many miles did she walk per hour? In this case, it's like saying, how many marbles fit in each group? They gave you the total. They are splitting it up into groups of time, 2 different hours. How many miles did she walk per hour? Meaning, what's the size of each hour? Okay, this is division. They gave you the total. They gave you the number of groups. Now they want to know what's the size of the groups. Okay, now I know it's a little weird. That's why we're doing this. We're going to continue working on this together. But when your mind is visualizing this, this is one way to look at this. Okay, now it's not 2 hours, right? It's 1 2/5 hours. But ultimately, here's what we have. We have the total, 3 1/2. divided by not 2 hours, it's divided by 1 2/5 hours. And there's our math problem. Okay, so here we go. Convert. So at this point, I'm just doing our normal steps. So 2 times 3 is 6 plus 1 is 7, so we have 7 halves. Divided by, and then I have 5 times 1 is 5 plus 2 is 7, so 7/5. Now I'm going to use KFC. Now you guys should be working downwards. I'm running out of space here. So 7 halves divided by 7/5, KFC. I'm going to go ahead and keep the first, flip the second to write the reciprocal of 5/7, and I'm going to multiply. Now I'm going to cross reduce. In this case, look at this, 7 and 7. They basically cancel out because they both are divided by 7 to give us 1. And we now multiply straight across. 1 times 5 is 5. 2 times 1 is 2. Now, this is a word problem. So remember, with fractions, you need to do 2 things. You need to make sure that it's in mixed number form with a word problem, and I need to make sure there's units on there. So here we go. 2 divided into 5. 2 goes into 5 2 times without going over. That would be 4. 5 minus 4 is 1. And then, of course, the denominator, is 2. 2 and 1/2. Now, listen. The other thing is, and the reason why I want to do this with you is because we haven't talked about unit rates yet this year. Okay, we'll talk about that next chapter, actually. So I'm going to kind of give this to you. It's talking about her walking pace. That's a rate, okay? And a rate will have 2 units in it. In this case, it's 2 units that you guys have heard before. It is miles per hour. And that's what we're going to write, miles per hour, and some of us know it as MPH, okay? So miles and hours are both in the units, but it's miles per hour. For every 1 hour, she walked 2.5 miles. Okay, I'm a little worried because the calculations were good. When we got to this point and I start talking about word problems, which is a big portion of our Chapter 4 test, our Unit 1 test, I should say, our next test on Chapter 4, word problems are going to be all over that thing. Okay, tomorrow night's homework, a bunch of word problems. That's why we spent so much time, but a lot of our eyes just glazed over when we started talking about word problems, and some of us were looking at the clock, hoping class was over very soon, okay, and okay, that's not the time to zone out, because this is very, very important to understand how to convert it from a word problem to a computation problem, a problem that we're used to doing and solving, okay? So, any questions about this to this? Okay, so listen, I am going to give you, we're going to work on one of your problems off of, we're going to work on one of our problems off your homework together. We're going to start it together because there's a little extra twist I want to introduce to you. I'm not going to require you to do it on your own homework. But that is, if you take a look at page 331, and let's take a look at problem number 7. Okay, problem number 7. Okay, on number 7, let's go ahead and close read number 7. Here we go. Cheryl is organizing her collection. If each movie is 3 4 inches wide, 3/4 inch wide, how many movies can on a shelf 5 1/4 feet wide? Okay. Now, here's the thing. I'm going to go ahead and draw a diagram. Again, now this diagram is a line. It'll look just like this one. But this isn't how much was walked. This is the shelf that the movies are being put on. This shelf has a total, like how I said that, 5 1/4 feet wide. The total width of that shelf is 5 1/4 feet. Now, the other information they say is each movie case is 3/4 inches wide. There's a Blu-ray case. There's the next Blu-ray case. There's the next Blu-ray case. Okay, you don't have to draw all this, but you guys get the idea. Now here's what the most important part is. This little width here, the width of that Blu-ray case, they said is 3/4 inches wide for one of them. Now this is an issue that we haven't talked about this year, but you'll need to know. When you're doing mathematics and you're going to solve a problem, okay, we've talked a lot about units this year, but before you start solving it, you have to make sure the units are the same. In this case, the issue is this is measured in inches, this is measured in feet. We need to convert this to inches first. We have to find out how many inches wide is this shelf before we do any kind of math on this. Okay? Now, let me ask you guys, if this, and again, remember solving a simpler problem, if this was 5 feet wide, how many inches wide would that be, guys? Those of you that, what is it? 60? How did you figure that out? By 5 times what? Okay, where'd you get the 12? That's how many inches are in feet. I think that deserves a nice jolly rancher. Well done. Okay, guys, we're converting it. How? Because 12 inches in 1 foot. So if it's 5 feet, you just say 5 times 12 and it would give you 60 inches. Now, solving a simple, this isn't 5 feet. This is 5 1/4 feet. But the conversion doesn't change. We still say 5 1/4. Instead of 5 times 12, we say 5 1/4 times 12. When we solve this, this will tell us how many inches there are. All right? So thank you, those of you that are writing it down. Here we go. I need to convert first. So, and remember, this isn't division, so there's no KFC involved. Don't start getting KFC happy and doing KFC with everything. It's only with division. Okay? It's just multiplication. So 4 times 5 is 20 plus 1 is 21. So 21/4. And then I'm going to make sure that I convert this to an improper fraction, which is 12/1. No KFC involved, but I can cross reduce right here. 12 and 4. I can reduce both of them by 4. 4 divided by 4 is 1. 12 divided by 4 gives us 3. Now I multiply straight across. 1 times 1 is 1. That's our denominator. 21 times 3. You can go over to the side to solve it if you want, but 3 times 1 is 3. 3 times 2 is 6. It's 63/1. Or in this case, 63 inches wide. So this is 5 1/4 feet, but if you're talking about it in inches, which we need it in inches, it's 63 inches wide. Now we have it in inches here and in inches here. Okay? So we haven't talked about this. That's why I wanted to do this part with you. But now it is set up for you to go ahead and solve that word problem. Okay? Remember the question says, all right? The question says, how many movies can fit on that shelf? All right? Okay. I'm going to go ahead. I'll give you guys a couple of minutes to go ahead and do number 7. All right, if you finish early, go ahead and finish up or try to finish up a lot of your homework. So 2 minutes. Number 7, go. Okay, 30 seconds. Go ahead and turn to your neighbor. If one of you guys aren't done, then the neighbor help them out to see what they're missing. Okay, so 30 seconds. Go ahead and turn to the neighbor and share. Go. Well, think about it. If each movie is 1 inch, how many movies would you fit on that shelf? How big is the shelf? If each of them was 1 inch, how many movies would you fit on that? No, you fit 63. Each of them is 1 inch. But it's a little less than 1 inch, so the answer should be a little more than 63, right? Okay, so listen. I was just having a discussion with one of your classmates. Said, let's think about this. If each movie was 1 inch, which is a little more than 3/4 inches, right? If each movie was 1 inch, how many movies would be able to fit on this shelf?
63.
63 of them, because it's 63 inches wide. So now, because each movie is a little skinnier, you should be able to fit a little more than 63. So if your answer is like, oh, I fit 15 movies on it, or I fit 1,026 movies on it, you know that's neither one of those are going to be good answers, right? It should be a little more than 63. So just kind of getting a good idea of what's reasonable. So here's what you should have done. The total is 63 inches. That's like saying the total of marbles is 6 marbles. So the total is 63 inches. We are splitting it up into sizes that are 3/4. That's like splitting this up into 2 marbles per. In the end, we want to know how many movies fit on here, which means like how many hula hoops do we need on that easier problem. So here's what you're doing. You're taking 63 and you're dividing it into 3/4 inch sections. That's all. That's your math problem. So we have converting this to 63 over 1. And then we use KFC, 63 over 1. Flip this, right? 4 over 3. Change that to multiplication. Now, cross-reducing this here can be a little more challenging for some people, but you can cross-reduce that. You can divide them both by 3. This becomes a 1. This becomes a 21. And now when we multiply straight across, 21 times 4 gives you 84. 1 times 1 is 1. Ladies and gentlemen, 84 movies. Let me ask you, is 84 a little more than 63? Yeah. So that is a reasonable answer. And that works. Okay? Questions? Okay.